Hello, welcome to my channel Teach Me, and in this session we are going to see the structure of atom, and the main points we are going to look into the details of how the discovery of subatomic particles led to a better understanding of structure of atom that we see today or that we understand nowadays. So around 1803, Michael Faraday was doing research on the topic of electrochemistry. It is a reaction between electricity and chemicals. So what he did is he passed electricity into a chemical and observed the difference in mass of those two electrodes used to pass electricity. And he noticed that there were changes in the mass of electrodes. And a detailed study of this type led him to propose or write the laws of electrolysis in the year 1833. Although he did not directly discover electron, somehow his work on the topic of electrochemistry led to a discovery of electron, or set a path to understand how electricity is conducted or carried in chemicals or various other metals or various other elements. Though this sort of curiosity or was not understood or eager to know that led many other philosophers and scientists of that era to study or to understand the structure of atom. So electrochemical experiments contributed to the development of concept of electron, and the contributions by Michael Faraday were laws of electrolysis, Faraday's laws of electromagnetic induction, and Faraday's tubes of force. Here what you see is an example of electrochemical cell in which there are two electrodes. One is called cathode and the other one is called anode, which is positively charged, and electricity is passed between the cathode and the anode. Within this cell, the current is carried through the medium called electrolyte. The anions or will be directed towards the anode. So anion are negatively charged ions, and the negatively charged ions get attracted towards the positively charged electrode, which is called anode, and the cations are the positively charged ions which gets attracted towards the cathode electrode, so which is negatively charged. And the external power source, a DC power supply, supplies the electricity, and the direction of flow of electron here is marked as plus to minus. That is the direction of flow of electrons, and the direction of flow of electricity is opposite to that, as it is understood from the concepts of physics or any other subset of science that deals with current. So the main important point that we take from this slide is that Michael Faraday's work on electrochemistry led a groundwork for electrical discharge phenomena. What is electrical discharge phenomena? This is what, when you pass electricity between the two electrodes, which are cathode and anode, and the chemicals inside that get discharged Based on that, the anions and cations are getting attracted to the respective poles, and that phenomena is called electrical discharge. In the time frame of 1869 to 1875, William Crook, the famous scientist here, came up with his device called cathode ray tube, which set a foundation for JJ Thompson to discover electron at a later stage. So let's see what the William Crookes cathode ray tube is all about. He made this tube, and the tube is completely evacuated, which means there is nothing left except a small amount of air inside the tube. And the vacuum was set inside the tube. So if you measure the pressure, which would read 10 to the power minus 6 to 10 to the power minus 8, which will be in this range of pressure. And then he applied a very high DC, direct current voltage, between the two electrodes, which is anode and the cathode. And when he applied such a huge potential or a DC voltage, he observed that the cathode rays were generated by the ionization of residual air inside the tube. And when the small metal cross was placed inside the cathode ray tube, he observed that it either casted a shadow on the backside and inside of this cathode ray tube, which was coated with fluorescence or phosphorescent materials like zinc sulfide. So these cathode rays that emanated from the cathode passed through the metal cross, and because it is a metal, I think it acted as an electron sink, and whatever electron that passed through hit the metal got absorbed, and wherever there was no metal or any such symbol, then those electrons hit the inside of the cathode ray tube, and it glow like we see here in this picture, which is very well captured in the dark image. So cathode, anode, and the metal cross here. High voltage is applied, cathode ray generated from the cathode, and it passed in a straight line, or it passed directly from the cathode, and it casted a shadow on the inside the cathode ray tube. So the key thing here we want to understand or to know is it was William Crookes cathode ray tube which generated cathode rays, and he clearly able to produce the cathode ray. Later we will see how this work by William Crookes led to the discovery of electron and identify its characteristics, the first subatomic particles that was discovered in the history of atom. 1897 cathode ray experimental setup by JJ Thompson led him to calculate the charge to mass ratio, that is the charge of electron divided by the mass of the electron, which he calculated 1.758820 into 10 to the power 11 coulombs per kilogram. So this key number, which is a formula or which is the main discovery of JJ Thompson, along with the proof of existence of electron, which was the key fundamental subatomic particle that leads to the passage of electricity or conductivity in case of electrochemical reactions, which Michael Faraday did in the previous, yeah, 50 years ago. The setup by JJ Thompson to study the cathode rays was shown here. Similar to the Crookes tube, the backside, the inside tube of the cathode ray tube setup was coated with fluorescent materials, and that is called the fluorescent screen. A cathode and an anode. The anode is perforated here, as you could notice. It is having a small hole in it. Right? The anode is perforated. Applying a high voltage between the anode, which is positively charged. Anode means positively charged. Cathode is negatively charged. So the cathode ray emanating from the cathode, because of its attraction, it could pass through the perforated anode, which is positively charged, and it travels in the straight line. And it happens whenever it hits the point B, or you could call that it travels straight when there was no electric, you see here, electric field of in perpendicular to the direction of this cathode ray traveling was applied. In this absence of electric field, it travels straight. When you apply an electric field, when he applied the electric field, then he noticed that because the cathode ray tube was negatively charged, the cathode rays were negatively charged. When he applied this negative and positive polarities in this direction, because of electron having a similar charge, it get deflected from B to C. And similarly, if he reverses it, he could notice that what you would expect, it would hit point A if you reverse the direction of applied electricity. In that case it would be D. But what he did is he would have studied that as well. But later then he applied this magnetic field. So in that situation, he noticed that it hit the spot A. And by carefully adjusting or equating this magnetic force and the electric field, or the magnetic field and the electric field, he was able to bring back to the initial stage point B without, as if there was no electric or magnetic field applied. So with that deflections and the amount of electric field and the magnetic field that were required to bring back the deflected rays of cathode ray inside the cathode ray tube, he was able to calculate the charge to mass ratio. And here is the summary of cathode ray experiment. Cathode ray starts from the cathode and it travels towards the anode. It wasn't visible to the naked eye, but it left a glowing spot when it hit on the fluorescent or phosphorescent coated materials on the inside of the cathode ray tube. The olden day television picture tube used this technology to produce pixels or the pictures of color that in the color television. In the absence of electrical or magnetic field, these rays travel in a straight line. And in the presence of electric or magnetic field, the behavior of cathode rays are similar to that expected from the negatively charged particles, and indicating that those rays are nothing but negatively charged particles called electrons. The characteristics of cathode rays or the electrons did not depend upon the material of electrode, which is a very important aspect. It did not depend upon the type of electrode that were used to build or construct the cathode ray tube, and the nature of gas that was present inside the cathode after the complete vacuum or partial vacuum was obtained, indicating that these fundamental particles or the cathode rays are independent of the source from which they were generated, and giving a hint that these particles or subatomic particles were indeed identical and same in every other element or almost every chemicals, leading leading the JJ Thompson to identify it as a fundamental subatomic particle that is negatively charged, and he called that as electron. Here, next we are going to see how Millikan worked out to calculate the exact charge of an electron based on his experimental setup called Millikan's oil drop experiment. Here he constructed two different plates, and these plates were connected to the external power source, positive and negative. Here, this small cylinder, this is called atomizer, from which the oil droplets were spread inside in the apparatus. They were made it into a tiny particles like you see here. These are all oil droplets. And these oil droplets were positively charged by nature. And because of that, the negative plate with the perforation led to pass those positively charged oil droplets, and once it enters through this perforated plate, it experiences a repulsive force because of the plate that is positively charged, and these two plates were separated by a small distance d, and there were a uniform electric field because of the applied potential in the order of several thousand volts. So these charged oil droplets were deaccelerated or slowed down, and it reaches to the to this plate very slowly, which was even observed or could be visualized by the naked eye through a microscope. And with that kind of experiment, he was, by balancing the gravitational force to keep the oil droplets suspended, he was able to utilize the force required by the electric field to prevent it from falling down. He was able to calculate the charge of individual electron, and he calculated it as minus 1.6, and which is now with a higher significant number with a more accurate value, we know is minus 1.602176 into 10 to the power minus 19 coulombs. Here is a picture of our Millikan, and this is the original equipment or apparatus used by Millikan to perform his oil drop experiment. Let's move on to the next one, which is the mass of electron. I mean, with the informations we had earlier, the charge to mass ratio calculated by JJ Thompson, and later Millikan's oil drop experiment calculated the exact charge of electron by Millikan. So with these two informations, it was easy to extract the value of mass of electron. How? This is how they were able. So by dividing the charge to mass ratio from JJ Thomson's work and the charge of electron from Millikan's work, yields the mass of electron, which is 9.1094 into 10 to the power minus 31. And it is worth remembering these numbers. Discovery of proton and its characteristics. How proton was discovered and led us to understand the structure of atom with more clarity or much details. Goldstein modified the cathode ray tube apparatus which was studied by Crookes or the Crookes cathode ray tube. The modifications that he did was, instead of having the perforated anode, he made the cathode as the perforated one and noticed what we now know as positively charged species or the protons. When he used hydrogen, in that case, he would have seen the protons or whatever the positively charged species that is left inside, which is nothing but the proton in that case if it is a hydrogen. So the remaining experimental setups were same. Anode, positively charged one. The cathode, negatively charged one. And has the perforations instead of the anode as compared to the previous work by William Crook. So the cathode ray emanated from the cathode and it passed towards the anode, and the gas, residual gas, which is left inside the vacuum tube has certain fraction or a proportion of hydrogen in it, or he intentionally filled it with hydrogen in the beginning and let the complete vacuum, which resulted in a few residual atoms of hydrogen left in it. So in that case, monoatomic hydrogen, here it is shown, would get ionized, and that led to the H plus electron, H plus which is nothing but a proton, and it passes through these perforated cathode, and he was able to see different colors in when he filled it with the different other gases, so which is called Goldstein's modified cathode discharge experiment. And based on that, he also calculated the mass to charge ratio for the proton. And the key things of his discovery were the production of Canal rays or positively charged rays inside the cathode ray tube. And cathode and anode has the same notion, and cathodes are negatively charged, anodes are positively charged. And the perforated cathode, high voltage applied in between the cathode and anode, a stream of electron from the cathode started to pass, and the modified cathode ray tube is filled with various gases like helium or neon, and he noticed different colors of uh, rays inside the tube when he changed these gases. The characteristics of the Canal rays are they are positive in nature, and he called it as anode rays or Canal rays. And ions were nothing but the atoms that lose one or more electrons, and those ions are called cations, which are positively charged. And they were also get deflected in the field of electric or magnetic field, and based on that he calculated the mass to charge ratio for those uh, positively charged species. Now, the discovery of nucleus and its characteristics. It was the work by Rutherford which led to our present day of understanding that atom has a nucleus and that is positively charged. And the famous gold foil experiment that he did led him to conclude that and propose the nuclear model of atom. In that experiment, a thin foil of gold in the order of a few nanometers were made, and that gold foil is bombarded with the source of with alpha particles coming from alpha source, and those alpha particles are nothing but positively charged helium atom. When helium loses more than two of its electron, we it becomes helium 2 plus, and these particles are made to collide on the gold foil, and he put a screen which is similar to the one of a coating used in the cathode ray tube, a phosphorescent or a fluorescent materials like zinc sulfide type of materials. So these positively charged alpha particles, these positively charged alpha particles went straight through the gold foil and hit the screen, and he observed this mostly, like they all hit these parts, but some of them got deflected to a certain or a smaller angle, and the magnified picture of the gold foil is given here, and what we see here is gold atoms, these tiny um, dots where its nucleus, and whenever the alpha particles passes closer to the nucleus, it get deflected because the nucleus is also positively charged, or indicating that the nucleus is positively charged for the first time. So because it experienced the same force, it carries the same force, it experiences a repulsive force and thus it gets deflected. Whereas a very few in the order of 0.005% of the whole number of alpha particles that were coming out or that were hitting the gold foil, about 0.005% of them got deflected back, or almost it bounced back in this case in this direction, or in a very about 180 degrees of deflection. 180 degrees of deflection was noticed, and that led Rutherford to conclude that the atom has a central nucleus, and that nucleus is very tiny, and the remaining space in the atom were mostly empty, and in that empty space the electrons were orbiting around, or the electrons were distributed in it. So that model which he proposed after his gold foil experiment was called Rutherford's plum pudding model. We will see the discovery of neutron and its characteristics in this section of video. Neutron is a subatomic particle with a symbol denoted by the symbol N or N superscript O. The charge of a neutron is neutral and it's not positive or negative. The mass of a neutron is slightly higher than that of a proton. Protons and neutrons together constitute the nuclei of atoms. In the previous work by Rutherford, it was concluded that the central part of the atom was positively charged. Right? Here in this section, we are going to see how James Chadwick's experiment in 1932 with alpha particles that were bombarded to the surface of beryllium led him to discover a neutral radiation which is consisting of neutrons, and that work led him to solve the mass deficit problem of the nucleus, because you remember that in the notion of A, Z, X, this is the shorthand notion of the elements which we saw, or which we will see in the later stage. A is atomic mass, and Z is atomic number, which is equal to the number of electrons or the number of protons present in the atom. Z, or the atomic number, is a unique identifier, unique ID for every single atom, which means, like, if you have a UID or an atomic number, then that represents only that particular element in the periodic table or element that is ever known in the chemistry. The atomic mass is the summation of the number of protons plus the number of neutrons. The number of neutrons, which is atomic mass. So the atomic mass is also the mass of almost the mass of any atom. Why? The electrons are having a insignificant mass, or contributes to the mass of an atom insignificantly, because these are very light and very particles that doesn't contribute to the weight of the atom, whereas the proton does contributes, and the atomic mass is the summation of the number of protons and the number of neutrons. So, without the confirmation of the presence of a neutron inside the atom, the whole weight of an atom was not able to, clearly picturize, or was not explainable in terms of the mass of the number of protons and the number of electrons that were known before the discovery of neutron. And also the presence of neutron uh, were were indeed very helpful to explain the existence of isotopes. Isotopes are the elements, are the atoms of same elements with same atomic number but has a different atomic mass, which means they have a slight difference, or only the number of neutrons in that varies. So those are called isotopes. So with the discovery of neutron, the isotopes were better explained, and the mass deficit of nucleus was solved, leading us to understand the, the atoms very clearly. So now, with the discovery of neutron, isotopes were better explained, and we were able to exactly account for the mass of atom with the presence of neutron and protons inside the nucleus. And here is the picture of the person who contributed to the discovery of nucleus, or neutron in particular, in the nucleus. And he later proposed a model of atom which is popularly called as nuclear model for atom. Now let's check our understanding by answering the two questions here. The first question: select the correct set of answers from the given choices for questions 1, 2 and 3. So in one question you have 3 sub questions. The first sub question is: canal rays or anode rays consist of positively charged particles. True or false? It is true. Cathode rays are negatively charged. That is true as well. We saw that. Atom consists of equal number of protons and electrons. Is that true? Yeah, that's right. The answer is choice D, which says true, true, true. Right, that is the right choice we have to select. Question number 2. The discovery of dash supported the existence of isotopes. Electron? No. Neutron? Yes. So it was the discovery of neutron with which you could better explain the existence of isotopes, which has the different number in neutron, or it differs only by the number of by the number of neutrons present in it, right? So which is A is equal to the number of electrons or protons plus the number of neutrons. So only the number of neutron differs, and thus the atomic mass of the element differs, which in turn leads to a different isotopes. And the Z will remain same, which is the unique identifier or unique ID for every element. So the choice you have to select is B. Hi. The third question here is select the correct set of answers from the given choices. The choices are given here, and the questions, three questions, 1, 2 and 3. So the first question is Dalton's atomic model explains the charge nature of chemicals, and charge to mass ratio of electron could be deduced. No, he never talked about charges or charge nature of any such elements or atoms. So it is false for the first question. The answer is false. For the second question, JJ Thompson was the first scientist to show the charged particles. True or false? False. Why? Even before JJ Thompson, Crook was studying his electrical discharge phenomena in the gases, and before Crook, it was Michael Faraday who studied about the electrical discharge phenomena in the chemicals or liquid solution state or electrolyte in liquid form. So the answer is false. So the third one, though Faraday's law of electrolysis deals with electrochemical reactions, will it obey law of conservation of mass? Yes, it will. True. So the answer you have to select is false, false, true. It's the right answer. Thank you for your attention, and thanks for subscribing to my channel. Thank you for watching this video. The key things that you have to remember is the charge to mass ratio as deduced by JJ Thompson's work, which is 1.758820 into 10 to the power 11 coulombs per kilogram. And from Millikan's oil drop experiment, the charge of an electron was calculated, and the precise value of that is minus 1.602176 into 10 to the power minus 19 coulomb. From these two values, one could easily calculate the mass of electron, and the value of mass of electron is 9.1094 into 10 to the power minus 31 kilogram.